Today's notes are on the number e. The number e, called the natural base or Euler's number after it was discovered by Leonhard Euler, has a value of approximately 2.7182818284459, which you can find by looking at the quantity 1 plus 1 over n raised to the power of n, and as n approaches positive infinity, and you can see it illustrated below. For example 1, you're going to evaluate the following expressions using a calculator, rounding your answer to 3 decimal places. You're looking for the little e on your calculator. It is usually found by hitting the second key first. If you type e raised to a power, so you're using the caret key of 2, you should be getting a value of 7.389. If you raise e to a power of negative 0.06, you should be getting a value of 0.942. Try and plug the last 2 values into your calculator on your own. We will check them in class. For example 2, you're going to use your exponent rules in order to simplify the national base expressions. So for a, when you have 2 of the same base raised to a power, we simplify them by adding the exponents. So I have 3x plus 4x, which gives me e raised to a power of 7x. For letter B, I'm going to start by simplifying 10 over 5, which gives me 2. Then, because I have a base of e in both the numerator and the denominator, I'm going to take the exponent in the numerator and subtract it by that in the denominator in order to get 2e squared. The last one we are going to do together is c. In order to simplify this, I'm going to make sure that 2 attaches itself to both terms inside the parentheses. So I get 3 squared times e to negative 3x times 2, which gives me 9e to the power of negative 6x. And because we don't like negative exponents, we're going to move e to the 6x power to the denominator. Please simplify d and e on your own. We will talk about them in class. You should have skipped the second page. We will talk about graphing the functions together, but we are going to look at the model for continuously compounded interest. It is found using the equation a equals p times e raised to the power of r times t. Just like before, p is your initial amount, r is your interest rate expressed as a decimal, and t is the years that have passed, a giving you your final value after the years have passed. E will not be replaced with a number as it is its own number in your calculator. So to start, we're going to identify the values of p, r, and t. So you deposit $1,000 in an account that pays 8% annual interest, so 0.08, compounded continuously. What is the balance after 4 years? So when you see the words compounded continuously in your problem, that is how you're going to know that this is the equation that you're using. So plugging it in, I get a equals 1,000 times e raised to a power of 0.08 times 4. And remember, as you plug this into your calculator, to put parentheses around the 0.08 times 4. You should get a is equal to $1,377.13. Let's look at one more example together. In 2011, you deposit $850 in an account that pays 6.5 annual interest compounded continuously. What is the balance in 2016? Your initial amount was $850. The rate is 0.065 written as a decimal. And the time is 5 years, because 5 years have passed between 2011 and 2016. So we get A is equal to $850 times E raised to the power of 0.065 times 5. Again, putting that in parentheses as you plug it in your calculator. You should get an answer of $1,176.43. We will answer all other questions together tomorrow in class.